So good evening, distinguished guest, esteemed INAE fellowships and dear participants. I'm Dr. Gopika Vinod, Secretary INAE Mumbai Chapter. It gives me immense pleasure to warmly welcome you all to today's webinar, which is organized under the auspice of International Academy of Engineering, INAE Mumbai Chapter. We are truly honored to have with us the distinguished industry leader who brings decades of rich experience and deep insights into the field. It's my privilege to welcome Mr. Vivek Chinoy, Director of Electronics Devices Worldwide Private Limited, Vice President of IPMMI and Executive Committee Member of IPMMA. He will be delivering a lecture on From Containment to Intelligence, the Engineering Evolutions in Solutions to Industrial Packaging System. So on behalf of INAE Mumbai Chapter, I extend a very warm welcome to you. We look forward from benefiting from your expertise, practical insights and vision for the future intelligent packaging system. I also extend a warm welcome to all our distinguished guests, respected members of INAE fellowships, industry professionals, and all participants who have joined here online through our online platform. At this juncture, I would request Chair INAE Mumbai Chapter, Sri A.K. Balasubramanian sir, to kindly deliver the opening remarks and set the contours for today's deliberations. Over to you, sir.
Thank you, Dr. Gopika. Distinguished INAE fellowships, various participants, ladies and gentlemen, a very good afternoon to all of you. Well, there are many drivers for our country's progress towards a developed country, that is Viksit Bharat. And supply chain is one of the very important domains which will contribute to a great extent. Efficiency, cost effectiveness, and sustainability, etc., are the key attributes of a successful supply chain. Application of technology and engineering, as well as leveraging innovations in these fields, are hallmark of any business activity which is treading a very progressive path. Today's lecture, I understand, will bring out engineering solutions and evolutions in industrial packaging systems as a part of efficient supply chain, a very relevant and interesting topic indeed. I warmly welcome today's speaker, Mr. Vivek Chinoy, for delivering this very interesting topic to the benefit of INAE Mumbai, INAE fellowships, as well as all other participants. Thank you very much. I want once again welcome all of you for this webinar. Over to Mr. Vivek Chinoy. Thank you.
Vivek Chinoy is a practicing engineer entrepreneur with nearly 25 years of experience in packaging automation, specializing in induction sealing, cap and closure assembly, and integrated packaging system. He worked in the automation of plastic. He serves as the Director of Electronic Devices Worldwide Private Limited, a global packaging automation company with installations in over 80 countries. His work in the automation of plastic caps, closure and enclosure spans medium to high speed systems designed to meet stringent global standards. So this includes the deployment of 360-degree vision inspection, inline quality assurance and robotic automation for high throughput environment, supporting the transition towards smart factory architectures with improved reliability, traceability and process control. His broader focus includes engineering solutions that enhance safety, energy efficiency, regulatory compliance, and life cycle reliability in food, pharmaceutical, and chemical packaging. He has led the development of CGMP, Current Good Manufacturing Practice compliant CE certified systems, and played a key role in establishing a wholly owned US subsidiary to support regulated global markets. Beyond his corporate role, Vivek is actively involved in industry institution building as Vice President of IPMMI and Executive Committee member of IPMMA, contributing to the advancement of India's packaging machinery system. He is an alumnus of Father Ethnale's Electronics Engineering and SPGN Institute of Management and Research. Thank you for having you here with us for this webinar. Without much ado, it's my great pleasure to invite our speaker, Mr. Vivek Chinoy, to deliver his lecture. The screen is yours, Mr. Vivek Chinoy.
Thank you very much, everybody. And thank you very much, INAE, for inviting me here today and allowing me to speak about packaging. So most of us in this room have spent our lives engineering faster, stronger, and more reliable machines. Today, I want to talk about something different. Not machines that move faster, but systems that think better. This presentation is not about packaging as an industry. It is about packaging as an engineering intelligence system. Before I start my presentation, I'll take a moment to introduce my company that I work for. It is called Electronic Devices Worldwide Private Limited, and it was started by two technocrats, Mr. S.V. Chinoy and Mr. R.B. Singh, who in the past 51 years have delivered many solutions for the Indian industries and helping them grow and reach their goals. I will highlight a few of them. The starting product was dielectric preheater, which was used by many Indian companies, including ISRO, and it was exported to Europe since 1980. India got its first induction sealing system in 1989 by the same company. And then when the automobile and defense revolution started, they developed a host of induction heaters to offer metallurgical solutions. So the Make in India movement was started back in 1974. For nearly 5 decades, packaging engineering succeeded without intelligence. And that is not a criticism, it is a testament to human ingenuity. Machines executed instructions. They had no memory, no feedback, no learning. Engineering success lived entirely in the heads of experienced engineers. Early in that time, food was consumed where it was found. In 1970s and 80s, packaging actually played a very insignificant role in distribution and sale of goods. It was only considered as a container to transport items from point A to point B all across the country. If we look at packaging between 1970 and 1995, the dominant question was simple: will it hold? Paper, glass, tin plate, early plastics. Engineering was very mechanical, it was deterministic and manual. If we see, the GDP at that time was barely 62.4 billion, and in 25 years it grew 6 times, which is 360 billion. You might remember going to a doctor and him giving you a medicine in a glass bottle with a cork on top. That was the kind of packaging available at that time. However, it still contributed 10 to 11% to the GDP, not because it was intelligent, but because it was essential. Liberalization changed one thing fundamentally between 1996 and 2005: our expectations. Packaging was no longer just about containment, it was now about consistency, compliance, and credibility. There was a lot of advancements in the materials. PET bottles came into play, aluminium foil laminate liners started being used across, and multi-layer flexible packaging was also now the new normal. On the engineering aspect, we saw that the machines which were earlier running at 30, 40, 50 packs per minute were now being demanded for 120 packs per minute. These manufacturing plants across the country started asking for continuous production lines, and there was increased focus on consistency and repeatability. And we saw a small transition from electrical equipments to electronic equipments. This is where induction sealing quietly entered the picture, not as intelligence but as control. People wanted to control that they could move the product from their factories to consumers far away, hundreds of kilometers far away. And we saw that Indian packaging industry grew at that time from 15 to 20%. And this is also the time when a lot of foreign equipment started finding its place in India, because India wanted to also, in this liberalization phase, started to export. And to export, they needed more reliable, more faster machines which were available overseas. By 2010, packaging machines began to look intelligent, but they were not. PLC control gave us precision, standards gave us compliance, but the system still did not learn. We had automation, but did not have intelligence. Material science became more and more complex. PET bottles, clear transparency, multi-layer bottles, lot of improved polymers came into play. New closure design, cap and closure designs were used across the industry. In food, it was dispensing closures. In pharma, it was child resistant closures. In pesticide, they started using vented liners, so on and so forth. But the era started doing more serious engineering around it. In induction sealing also, we had to upgrade, because at that time a lot of pharma companies were filing their formulations in several countries overseas. Over 150 companies applied for US FDA and MHRA approvals. And to comply to that, we as Indian manufacturers had to up our game, change the infrastructure of our machines. Our water cooled induction sealers transformed into new air cooled systems. They had to be CFR 21 compliant, and also the fabrication had to be CGMP. Moreover, by 2020, these compliances matured so much that a sealed integrity testing system had to be devised to support this industry's demand. By this time, export oriented manufacturing also rose, and to match it, the Indian packaging industry stepped up. They started building equipments meeting global standards, meeting global regulatory requirements and safety norms. And by doing so, we as a packaging industry started contributing a growth of about 18 to 25%. I want to share a few facts about the packaging industry. From 2010 to 2015, the Indian packaging sector grew from 14 billion US dollars to 19 billion US dollars. Look at that value in 2020, it became 75 billion dollars. More than 3 times, the growth. But look at the consumption. The per capita consumption grew by 200%, from 4.3 kgs to 8.6 kgs annually. That is phenomenal, largely contributing to e-commerce growth. Around 2020, something changed quietly but permanently. Packaging stopped being an end of line activity. It became a part of the manufacturing nervous system. Filling, inspection, traceability, sealing no longer were isolated machines, but they became interconnected decisions. Machines had to sense, decide, act, measure, and improve. So, packaging became a learning system. While doing so, each of these machines, upstream and downstream, had to be integrated. Filling lines were integrated with online inspection systems, and they had to be connected to the sterilization. That means they needed data traceability all throughout the packaging line. Plant managers started focusing more and more on throughput optimization, reliability, process repeatability, and regulatory compliance. From sealing a container to protecting the product life cycle, this was the transformation that happened. By 2020, packaging was no longer an isolated end-of-line activity. These also gave rise and contribution to our overall GDP. In 2020, our GDP was 2.6 trillion, and today in 2026, it's almost $4.16 trillion. Induction sealing is not important because it seals caps. It is important because it sits at the intersection of energy, material, time, and compliance. Because of so much upgradation, we are able to offer audit trails to our customers. It continues to consume the lowest power consumption when compared per seal when compared to any other process. In my upcoming slides, I will also emphasize on zero defect sealing, which is now possible, and integration with real-time non-destructive seal integrity tests. Because of all these advancements, induction sealing became an industry norm and was started being used in over 150 industry domains. Anything that can be precisely sensed, measured, and repeated is a candidate for intelligence. Induction sealing moves from process to learning interface. Now, all of this could not happen without indigenous R&D. We are glad to inform that our R&D is world-class and is DSIR certified. We have established a world-class infrastructure for power electronics, control electronics, engineering, energy efficient induction sealing systems, and closed loop process control. We can proudly say that today our R&D department has published over 81 technical papers, of which 5 publications were selected for Best Technical Paper Award. We have received 5 patents and 2 are pending. There is India did not, become globally relevant in packaging by copying machines. We did it by building engineering depth. So for R&D, any of our, people who are in machine building or in the technology side, R&D should not be treated as a department, but it is a long-term cultural decision. Because of which we have also received many awards. We have received the prestigious National Technology Award for zero ventilated caps. Economic Times has recognized us for Innovative Company Award. We have proudly received 6 pack machine awards from IIP over 2 decades. The governor of Maharashtra has recognized us with the Pride of the Nation Award, so on and so forth. I want to deep dive a little bit more into what kind of innovation we have done and take you, through a little technical side of this presentation. I'm playing a small video. Here I will be showing and discussing with you 2 approaches on induction sealing. One is the technical approach and second is the innovative approach which we are following. In the technical approach, we see that in the induction heater, there is a power converter which generates the power and it is wirelessly transferred. And that wirelessly transferred power converts into energy and then energy is distributed. And that distributed energy is finally utilized. While doing so, in induction sealing, the power conversion is about 97% in the traditional process, and wireless power transfer is about 94%. Energy utilization is only 20%. Process efficiency is only 18.8%. This can be compared to any induction cooktop that you might be using at home or would have come across. Now, what are we doing different? What is ED's innovative approach? We became active in passive components, which is the coil design. And let me show you, we are going to reveal this for the first time in next few slides, what is actually happening inside the machine. The power that is converted is wirelessly transferred and at the same time it is distributed. So this is a unique approach. And because both the things are getting done at the same time, the energy conversion to heat is very, very high. And because of that, the energy utilization is superior. Let me show you a little more in detail. This is a this is our multi-head design of the ceiling head, where you can seal 20 to 120 millimeter foil. I'll play the video of two different bottle sizes. One is 18 millimeter, another is 120 millimeter. Both are getting sealed under the ceiling head at the same time with the same parameters, same line speed, same power setting. Only height is changing because of the bottle size. What we have done differently is zonal heating. We have divided the heating zones in four. Now, because of this, there is no hot spot and cold spot. You get uniform heating. As a result, the coil current reduces drastically from 180 amperes to 120 amperes. Power distribution is uniform and far improved. And that has led to zero defect sealing. Well, this is a patented technology. Now, when I say active and passive, I am taking you a little, as I said, we will be revealing a lot of, technology here. This is a transition from what was happening traditionally to what is happening today, and why it is smart, and how it is helping packagers to pack or seal their containers and transport them world over very comfortably without worrying about a leak. Back in the day, the water-cooled coils were designed like this, as the first drawing is shown. And here there was a limitation. You could seal only up to a certain diameter, maybe 70 or 80 millimeters. And then when you had to seal larger diameters, you had to have a different sealing head design. From there, we transitioned to Litz wire air-cooled coil. And here also we had similar topology where we could do only a certain diameter, and then to do wide neck jars we had to design a different sealing head. This was solved by designing a multi-segment air-cooled coil for wide range sealing. You can see these spheres here, this circular coil, and this is the new design where 18 to 120 bottles can be sealed very easily. To take it forward, these are the below three drawings are even more better advancement from there, because we are into continuous R&D. The first drawing that you see, it is made for a wide geometry of containers, which means that if you had a round container, square container, rectangular container, or a small dia, big dia, everything will get sealed under this sealing head at the same speed. The second diagram that you are seeing here is specially designed for wide neck jars. We had customers who were transporting ghee, dalda, adhesives. They wanted to transport this pan India, and they were facing leakages. And that is when we innovated this sealing head for 240 diameter. Uh, this can take care of such large diameters and seal them without any leaks. And the last design that I am showing you is a very, very innovative design where you can do multi-axis sealing without overloading the generator. It is insensitive to overload. These are some images of bottles when we actually tried them. I want to show you a live video of what is happening. You will see different geometry of containers. We have used some fixtures to put them on the same height so that it is easy to demonstrate various geometries getting sealed under one sealing head at same parameters. No need to change parameters. No need to even shift the sealing head. In some manufacturers, they prescribe tilting the sealing head. In our case, no need. Very, very innovative sealing head design. This is for wide neck drums. The green cap with the big drum. When you do this, it only does not allow higher sales for our customers, but also gives them a lot of confidence that they will have a leak-proof product traveling across the country or even beyond our country's borders. These are all oversized containers used by protein powder manufacturers, food supplement guys who have wide neck jars, and that can overload the induction heater. It doesn't overload the generator at all. Well, I have saved you the best video for the last. This is our latest multi-axial coil design where a matrix of bottles can be sealed under a sealing head without any leak. And this is happening for the first time in the world. Traditionally, all the bottles need to travel only from the center in one line, whereas here you will see that they are traveling in a matrix. This is first time in the world and very innovative design. This is also our patented technology. So which means that the same machine can now deliver using same power 3 times the speed. So much power saving, so much space saving also. All the bottles are perfectly sealed. I wanted to show you a little different perspective in terms of data, where you can see historically how the parameters have shifted and changed in this space. Back, this is all dated from 2002 because that's when most of our equipments moved from electron tube to solid state, and that's when the journey of improvisation began. Back in the day, let me start with the first one. Back in the day, in 2002, as I had shown you in my earlier slides, that sealing heads could seal only up to 7.5 centimeters in one sealing head, but now it can go up to 240 millimeters. Then, while doing so, the current has reduced. Earlier, we were using 180 amperes to achieve the same thing, whereas now we are using only 70 amperes. Power has also reduced. From 2.85 kilowatt, this power has come down to 1.42 kilowatt. Huge saving. And energy efficiency has happened. Earlier, energy was only 20%. I had shown you this in my traditional ceiling slide. And now it has all the way gone to 83%. So, power is getting fully utilized with very little loss. And the productivity has gone up. Earlier, the ceiling availability was 46 cubic centimeters per second per kilowatt, which has now come up to 258 cubic centimeters per second per kilowatt. So, lot of savings and lot of improvement in the overall design. While doing so, each of this application presented unique engineering constraints related to closure geometry, material behavior, line speeds, thermal sensitivity, and regulatory requirements. Well, by this time, regulatory requirements became more and more important, for which we had to design a new induction seal integrity testing system, which could do non destructive tests online and give real time data. Let me show you a video which demonstrates that. This is an induction sealer which is coupled to the seal integrity testing machine. The bottles are getting sealed. When you change over from one bottle size to another, there is motorized movement for both the vision system and the induction sealer. They are both CGMP compliant. Both these systems are connected to a CFR 21 compliant software and can offer high speed up to 120 bottles per minute. Before this technology was available, people had to open the cap and really check whether there was a leak or not. There was no other way to check. Now with this, it is inline. Huge advantage. So when a bottle travels under, you can see if there is a OK seal or without any foil, if it has no cap, if the heating is more, or there is a partial seal, or there is a weak seal. If the liner is cut or folded, or if the cap was loose while torquing, or there was no WAD, everything will get captured and rejected. Sustainability is not a slogan, it is an engineering outcome. Advancements in induction sealing, power, electronics, and control systems have resulted in this measurable energy saving. Compared to induction sealing systems available prior to 2002, 1 unit of energy is saved per machine per hour. Let me show you a little bit more numbers to show you what is the actual big data that we are saving here. Assuming that we work 325 days per year and we work 24/7, so annual operating hours are about 7,800. Energy saved per machine per year is 7,800 units. Now, with over 20,000 installed machines globally, total energy saved exceeds 156 million units of electricity. At an average cost of 10 rupees per unit, 156 crores of electricity cost savings have already happened. When you want to look at it from CO2 offset, almost 62,400 tons of CO2 has been saved, calculating it at about 0.4 kgs of CO2 emission per unit of energy. Now, this is true sustainability. That is an emergent property of intelligent engineering systems. If we would have not thought about it in this way, we could have not saved so much power, and we could not have a smaller carbon footprint. I want to share a few facts again. In 2026, packaging is woven into everyday life. It carries medicines across borders, supporting healthier lives worldwide. It preserves food, letting the world share authentic tastes. Today, you can sip Indian chai in Switzerland, enjoy hot samosa in Japan. It has made living easier. What began as protection has now become a connection. The Indian packaging industry was valued at $72.6 billion in 2020, and it is projected to reach $200 billion in 2026 due to rapid expansion in e-commerce, food processing, and pharmaceuticals. Today, Indian packaging industry is the fifth largest contributor to our GDP. The future of packaging is not faster machines. It is systems that observe, learn, predict, and prescribe. This definition applies equally to biological intelligence and engineered systems. I will show you a few futuristic systems which are actually deployed now and are in use. From AI-led future to systems that learn, that have become more intelligent on their own.
This is the world's most advanced e-commerce warehouse, run entirely by AI robots. This entire operation is managed by 48 Bright Pick auto picker robots. And these robots, they handle everything from replenishing inventory to robotically picking orders and getting them ready for dispatch. And that's how this facility, operated by leading sports nutrition retailer, The Feed, is able to work 24/7 and pick 50,000 items per day, all while just using a handful of actual people. That's right. This is the future of e-commerce fulfillment.
So we just saw a large warehouse where material, several parts can be picked and dispatched without any human intervention, and which works 24/7. Now let me show you a video where AI is used for packaging product design.
Look at this. All these packaging designs I created using AI within minutes. So for taking inspiration or sending your proposal fast enough to your client, use this kind of AI tool.
So what will happen is when you are using AI, it will learn consumer patterns and what didn't work for you, and it will correct your packaging design so that it becomes more consumer friendly. So opening, closing, material, everything, even engineering processes can be defined using AI. Now this third video is courtesy of Ulma, and it is a fantastic video of how AI is being deployed while in actual packaging machines for ease of maintenance and installation.
Is using AI as a way to predict outcomes. So do you think you could sort of break that down for me in lay terms?
So I think when we talk about, Joni, using AI to predict outcomes, what we really mean is part of the AR experience is confirming certain things are done. You know, in order for the experience to confirm that, yes, I've replaced a certain component in the proper manner, as the operator, you could be looking at that from different angles. So how many images or processes do you need to upload so that the system or experience can say, yes, you've done that correctly? So what we use the AI for is we can maybe take some physical images of the highest probabilities of where someone may be installing a change part or doing a rebuild, but then we're going to use the AI to supplement with synthetic data all the other angles and photos that could be created to ensure that depending on whatever angle the employee may be working on a piece of equipment, that it's also going to confirm that it's also properly done. So what it does, it replaces kind of that brute force of, well, we need to take an image or a picture and upload of every single possible angle and combination that someone could do at tasks. Well, now we're using the AI to kind of predict those other angles and pictures and everything that could be happening. It's kind of what we're really using it for, is we're not necessarily predicting, will this employee complete it properly? We're predicting kind of all the data around it, the synthetic data, to say, yes, it has been done correctly.
Wow, again, it's just, I mean, it's incredible.
So we saw how AI is solving problems for our plant managers and production heads.
Look at this.
This is the world's
using
most
AI.
One moment, yeah. Intelligence is the ability of a system to learn from experience, generalize across operating conditions, and make progressive, better decisions over time under real-time constraints. So it's not only about AI, but you know how it is actually in industrial packaging. Intelligence emerges when machines do not merely execute instructions, but adopt their behavior based on outcomes, variability, and feedback. Variability means being performed on different pack sizes. So what makes a system intelligent? Observation naturally because of sensors. Learning patterns over time means how, you know, what kind of problems are being faced, whether there is a pattern and we can use AI to understand where the fault was and, you know, cure it at source. And then prediction, what will go wrong next, and then prescription, what should be done. But for all of this, we will need human judgment. So by using a lot of AI, since I'm talking about the future of packaging, hence there is a lot of mention of AI. You know, plant managers and maintenance heads will now have a dashboard like this on their screens, which will be very interactive. It will help them reduce unplanned downtime. It will help them improve maintenance efficiencies and extend machine shelf life. What does this mean? That earlier they were using automation, now they have transitioned to condition monitoring, and then it will help them take decisions supported by intelligence. A lot of work is also happening on voice-based AI, which means that you will now start talking to your machines as you're talking normally. A lot of people are using Chat GPT and other AI platforms, and how you talk to them now, you'll be able to talk to your machine in the similar way, where operators get assisted on maintenance issues. And these machines will now be able to provide real-time guidance in local languages. So this is a big advantage. So your machine could be shipped from India to UAE, to Africa, to China, to any part of the world, Italy, Spanish speaking countries, and language will no more be a barrier. And you will not have to even code it in different languages. AI will do it automatically for you. So time to deploy these technologies will be much faster and much cheaper. It will also reduce dependence on experts available on site to do all of this. So installation will become easy, and maintenance will become more accurate. While doing all of this, we will have to maintain compliance. We will have to have a lot of digital traceability, end-to-end traceability from raw material usage to consumer. I think every product will have a digital passport. It will know where the product has begun its journey, in which plant, what time, what operator was there, which batch it belonged, and all the way throughout, you will have a digital passport of your product. And packaging machines will now become compliance platforms using new technologies. I am now going to take a case study of deploying AI and IoT on a bottle filling line, which has about 5 major operations: filling, capping, labeling, sealing, and coding. You will notice a pattern across every subsystem. IoT gives visibility and AI gives foresight. Visibility will tell you what is happening, while foresight will tell you what will happen next. Let's go ahead and see what's happening on a filling line. Typically on a filling line, even today, we are able to monitor flow of material per nozzle, and in real time we are able to track the volume. We will now, using IoT sensors and IoT devices, we'll be able to measure temperature and pressure compensation. It's just not pressure, but pressure compensation, and there will be automatic calibration alerts. But when you deploy AI, it will give you a predictive fill drift. And there are many materials which foam, so it will also give you prediction on when the forming will happen, largely in carbonated products. There will be zero giveaway optimization. All of this will lead to reduced product loss, improved accuracy, and optimized profit per batch. That's what we are all working for, right? Look at the capping machine. Using servo motors, we are actually getting real-time torque monitoring. Now with IoT sensors, we'll be able to even look at vibratory bowls which are used to feed these caps. We'll be able to track that vibration. And we'll be able to also see there is any thread wear out on the capping head. Using AI, this can be connected to seal integrity prediction and adaptive speed control and self-calibration. This will lead to less number of leakages and reduce micro stoppages. All of these lines efficiencies goes down because of micro stoppages. In high-speed labeling machine, imagine it's running on a big beverage line, and the roll tension is not accurate. It leads to a lot of defective products on the line. Now roll tension can be monitored. Even some adhesive based labels, the temperature tracking can be done, and changeover between pack sizes with accurate measurement can happen. Alignment feedbacks from sensor will happen using IoT sensors. All of this will lead to improved appearance of the package, reduce wastage, and faster SKU changeovers. Similarly, when we talk about induction sealing, even today, the current of the coil is getting monitored and we have a feedback loop. But then using more IoT products, we can do real-time seal validation on the seal inspection system. And the height of everything can be adaptive, recipe recall and all of this. No person is needed. Just put in a bottle and the whole plant will, all the ecosystem will know that a new product has come in and you have to generate a new recipe around it. This will give you improved seal integrity and lower energy usage and enhance product safety. Let me show you a new product line where this we had developed earlier, but now more and more advantages will come out of this futuristic packaging. This is called the capless induction sealer. The advantage you will get is that you can seal any kind of material. We are showing you a tin container getting sealed with just an aluminum foil using induction technology. So definitely a lot of saving on power, space, and flexibility of material usage. And since there is no cap on top, the sensitivity of the seal integrity testing machine will be much higher and more accurate. This can be done in different formats. This is a linear format. Now I'm showing you the same happening on a rotary machine. This can also be deployed for wide containers like 10 kg, 20 kg containers carrying viscous materials, powders. Also fully integrated with upstream, downstream equipments. The last equipment on a bottling line is the batch coding machine. When AI and IoT are deployed there, you can monitor many things which will improve the which can first of all do regulatory compliance. It will reduce rejections and improve traceability. What can be done there using AI? You can have intelligent print inspection. Legibility is also a big question there because sometimes it runs out of ink and it becomes a little faded and it's very difficult to be read by a barcode reader. So that can be improved and anti-counterfeit integration can happen. So all of this leads to a futuristic design which is more and more efficient. Well, AI does not replace engineers. It removes repetitive burden so engineers can focus on judgment. Intelligence amplifies responsibly, it does not dilute it. What is India's opportunity? Everybody is talking about India becoming the third largest economy. Now, when it becomes whether we will be standing outside and see this grow or whether we will participate in the growth. Well, I think India has a great opportunity to participate in the growth because strategically, India has got strong engineering talent. It has got a big infrastructure which can be cost effective. We have got good experience across regulated and high volume markets. India's opportunity is not to export machines, it is to export engineering intelligence, not speed, not cost alone, but systems that think responsibly under constraints. Packaging has evolved from containment to intelligence. The future will belong to systems that learn and engineers who design that learning responsibly. Well, India is ready. Let's create history together and making India a superpower in packaging. Thank you very much.
Thank you, Mr. Chinoy, for a very interesting presentation, taking the past, present, and future of packaging industry and giving a very lucid way of how AI and IoT, induction heating, everything is going to playing as well as going to play a big role. Now the forum is open for discussion. We will invite questions, comments, and reflections from our participants. Please feel free to raise their hands. We will first start with the question on the chat box. Okay, Sanat Kumar sir, you'd like to talk, or shall I read out?
What I wanted to know is, see, supposing you got a bottle in which you got a medicine and you are trying to seal it. No, that's a PET bottle. I am talking about a glass bottle, for example. Even PET bottle will do. Like any other glass bottle, yeah. So you got some medicine in it and you want to seal it. Okay.
Yeah.
So you are putting induction heating. What I am interested to know, just like that heating itself, will it cause harm to the product that you are sealing?
No, it will not.
Is it going to make any difference to the medicine that you are going to seal?
From last 30 years, it does not. I'll tell you how, sir. So this container travels under the sealing head. I showed you that the travel time is, even on a slow induction sealer, will be only about 5 to 6 seconds. So that the current that is induced here is only latent to the foil, and then the cap acts as a heat sink, and even the container acts as a heat sink. So all the heat is dissipated there and nothing reaches to the product. So when you open this inside, there is a fill level, right, which will be till here.
That's right.
We have sealed products with flash point of even 20 degrees. That means if the foil touches the product, it will immediately catch fire. That has also not caught fire.
Okay, thank you.
I hope I've answered, sir, in the right technical way.
No. Thank you very much. Yes.
My pleasure, sir. My pleasure.
Questions?
Yeah, Mr. Vivek, I have a question. This is Balasubramanian here.
Yes, sir. Good evening to
you. Good evening. See, this process, every process has got a kind of failure probability. So you must have evaluated the reliability or the failure probability. Number one. Number two is the industry. What is the regulatory requirements for such? Any number is there in that?
So most of the equipments are available. The OE is about 97-98%. Okay. The failure can happen because of several reasons, and there are fail check systems which are inbuilt into the machine to avoid these micro stoppages in the machine. One could be because of power fluctuation. So we have, because of power fluctuation, the sealing quality can change, right? We have an inbuilt system which will compensate the power loss and still continue to deliver a good seal. Second could be if this cap coming to the machine itself is loose or is tilted. That is also going to cause failure. And we have a sensor which is a through beam sensor. If the cap is more high, it will automatically detect and reject.
Yeah, considering all these possibilities and the the checks and balances built in the machine system, finally, what is the number that you achieve and what is the limit that is prescribed by the regulatory agency?
See, I remember going to, I cannot take names, but going to a big multinational company where their brand value itself is about, brand turnover is about 3,600 crores. And we were on that line for almost a week because they wanted to launch a new product, and we were collecting data, trying to ensure that it is reliable and it's running there. So what we achieved was 99.8%.
Okay.
And that was acceptable. Their acceptable limit was 99.6%, and we achieved 99.8%. So This is actually, and this was not a special design machine. It was just one of our standard machines.
Okay. Thank you. Thank you.
Mr. Arun Paul, any question from your end?
No, I do not have any questions per se, but I really thank you, Vivek, very much for very nice, excellent presentation. For covering wide range subjects in one lecture is very difficult. From materials to power electronics to control, process, IoT, as well as your artificial intelligence. It was an excellent presentation. But one of the advantages of these machines, what Dr. Sanat Kumar said, is that the ceiling defects will be very less because there is the distribution of power is proper, because in the earlier machines or even many machines by competitors, the distribution actually is mostly around the conveyor axis. So in that axis, more energy is there will be overheating, and perpendicular to that there will be under ceiling because less energy. So in our multi-segmented, multi-axis located coils solves that, and that too it takes much less energy, almost like maybe 50% or around 50%. And the same power electronics we are using, so each power component actually is lightly loaded compared to the old systems. So from that point of view, system reliability of the power converter has improved tremendously. Even the number of breakdown of the machine with 20,000 installations, per month we receive around 4 or 5. If you go to the MTPF calculation, it is very, very high. And field complaints are from power electronics control point of view, it is almost nil. There are certain process problems could be because of the process compliance. Maybe that's some crooked caps or something else. Otherwise, the system reliability has improved. What Mr. Bala Subramaniam actually just asked.
Sir, I have a follow-up question.
Yeah.
The seal, does it use any sealant?
Yeah.
If that sealant is there, what is the sealant you are using, or is it a trade secret?
No, it is a lacquer, and it could be a film. It is largely depend on the material of the bottle.
Yes.
So for HDP, it will be different. It is a sealant.
Good. Now, if the sealant can overflow into the medicine, is it possible?
It's a film. It's a film. It does not contaminate. It doesn't drip upon activation, upon heating. It does not drip.
Okay. Okay. Thank you.
If there are no more questions, we will move ahead with thanking the speaker. Today's webinar was a very is a milestone in our continuing journey of sharing knowledge and seeing the industrial activities. And this is INAE webinar continues to be a platform for this knowledge sharing as well as for nurturing this innovative ideas. So while we are on this, INAE Mumbai chapter would like to place on record our deep appreciation for the speaker, who has given a very lucid presentation and enlightened the audience. Our organizing team, INAE team, who have worked behind the scenes for making this webinar a good success. With this, I once again thank all the audience, INAE fellowships, and all participants who have taken out their time and joined this webinar. If there are any more, anything else we would like to discuss?
I would like to thank Mr. Vivek Chinoy once again for the wonderful presentation. And we at INAE Mumbai Chapter have had now an opportunity to arrange a topic on a very diverse topic like this, that is packaging. So it's been a wonderful experience for all of us. Thank you very much.
My pleasure, sir. My pleasure. I said likewise, it was a pleasure talking on INAE platform, where generally you guys discuss more on other serious aspects of life, like nuclear science and aeronautics. This is packaging, but it is serious because it contributes, $200 billion worth of GDP.
Yes,
And
indeed.
it is one of the, it is a pillar, for the Indian GDP to supporting the Indian GDP, and is also growing nicely. So I think it was nice to share on this platform. I would like to mention a special thanks to Mr. Arun Paul for mentoring me in this technical journey, and very, very special thanks to Professor VK Murthy, who is here today. He is my guru, and in my support, he is here attending this webinar. Thank you so much, sir. He is a very distinguished professor from SP Jain.
Thank you, Professor. Thank you very much.
Thank you. I think with this, we can formally close today's webinar. Wishing you all a very good evening and looking forward for continued association with INAE in future programs. Thank you.
Thank
My
you. Thank
pleasure.
you all.
Thank you.
Thank you very much.